Okay, let's begin the class. So in the yesterday class we have discussed about the Stork enamine reaction. Okay, so which is also a Michael addition type reaction. Okay, so in this we discussed what is enamine reaction and what is Michael addition. Okay, so based on that we have discussed the properties of the uh, products that are going to form with the regioselectivity, means specific site. Okay, so if the starting material is this and it's going to attack onto the Michael acceptor, so the resulting product will be, so it's going to move here, so it will be double bond, and here bond formation will be there, so double bond left, so it will be single bond and OH. Okay, so keto form and enol form. Okay, so after that saturated ketones. Okay, so it is carboxylic acid, so that will be as such without any disturbance in that. Okay, so once if I go for hydrolysis, it's going to give the carbonyl system. Okay, okay, so this could be the product. So similarly with this it will be, so if I add H3O plus also, if I didn't add water, so it will be up to imine formation. Okay, so if this is there, it will be double bond, and here bond formation will be there, so you can write directly. So remove this bond, it becomes single bond. Okay, so this will be the product. Similarly with this, alpha carbon of the carbonyl is going to attack, so that's why we call it as a alpha alkylation. So this will be the product. Okay. Hmm. So in this question, initially what I given in presence of base, when secondary amine is going react, so it is resulting into the enamine system. Okay, so enamine, just a minute, someone join. So if it is enamine and treated with Michael acceptor, so it's going to attack here, so it's going to move, it's going to move, so resulting what, double one n, so 1 2 3, 1 2 3, so this could be the product. Okay, so if I hydrolyze it, it's going to give the ketone. Okay, so next, so what are A, B and C? Did anyone tried? Full busy ఏమో, ఎవరు రాయలేదు పంపలేదు. So if it is diethylamine secondary amine, so it's going to attack to result enamine system, and enamine, if it is reacted with okay, so initially, so it is given step by step, so it's going to attack and it become OH and this become diethylamine. Okay, so when it is treated with base, it's going to abstract water, so release of H2O to result enamine. So this enamine, if it is going to react with the, sorry, carbonyl, sorry, so it will be onto the alpha beta unsaturated position. Okay, so it's going to give the saturated imine system. Okay, carbonyl with imine system. So if this hydrolyzed, it's going to give, so here it is a double bond. Simply we have added this whole group onto the alpha carbon of this carbonate. Okay, so that is the advantage of Stark enamine reaction. Okay, so next, so how to prepare or how to convert the starting material into this product? Okay, simply we can make enamine of this, and if I try to treat twice with the alpha beta unsaturated carbonyl, that is methyl vinyl ketone, so it's going to give this product. So what I mean is, so if this I treated with pyrrolidine and influence of base, automatically it's going to give the enamine or the pyrrolidine cyclohexane. Okay, so this, if it is treated with 1 mole of methyl vinyl ketone, so it's going to attack here. Okay, and followed by the hydrolysis, so resulting into what? Okay, if it is formed, and again I repeated the same sequence, pyrrolidine with base followed by the H2, followed by the attacking of the one more molecule of methyl vinyl ketone. So if it is attacked, and it's going to form the enamine system. Okay, of this, and if it is attacking, so again it's going to give one more Michael addition. So if it is treated with H2O, it's going to give double addition product. So this side 1 methyl vinyl ketone, and this side 1 methyl vinyl ketone addition. So this will be the product. Okay, is it clear or shall I repeat? Okay, so here in this we going to use 2 moles of methyl vinyl ketone, so that double addition of the Stark enamine reaction 2 times we are performing. Okay, so if you consider this as one attack or one part, okay, so how we going to synthesize? We going to treat this carbonyl with the pyrrolidine system, so that it will form enamine, and it will be going to attack the methyl vinyl ketone through Michael addition, so resulting into the saturated 1 5 carbonyls. Okay, so far it is known. Okay, so if at all the compound is formed, okay, so first addition has taken place. Okay, so and that if it is treated with one more molecule, okay, so this is the first addition product. Okay, this one is first addition product. If the same enamine reaction, if I performed once again with the same pyrrolidine systems, okay, so it's going to attack onto the carbonyl system. Okay, so again it is going to form enamine in presence of base. Okay, So this again it is going to attack on the methyl vinyl ketone. So resulting again the imine system with two attacks. Okay, through ketoenol tautomazone. This, if it is hydrolyzed, is going to give one more carbonyl group. So this could be the product. Okay. So next question. In 1,2 addition, the reactivity order. So you need to give the answer. So which could be the highest reactive in nucleophilic addition reactions? Why? Yeah. So nucleophile should attack so that it can be called as nucleophilic addition reaction. So if it is nucleophilic addition reaction, when a nucleophile is going to approach means it should have a electron deficient center in the molecule. So electron deficient center will be carbonyl carbon. Okay. So if once the carbonyl carbon attached to the donating groups, okay, so donating groups, so the electron density on the carbonyl carbon will increases. So electron deficiency will decrease. So nucleophile attack will also decrease. So hydrogen having aldehydes, okay, aldehydes are with hydrogen which is with neither donating nature nor withdrawing nature, so it will be comparatively less electron density onto the carbonyl carbon when in terms of the B. Okay, so whereas if it is C, it may be the withdrawing group according to the inductive effect, but it is a donating group according to mesomeric effect. So plus psi group will increase the electron density due to the resonance onto the carbonyl carbon. So which is even more electron density having carbonyl carbon when compared to other two. So it is the most electron density center. So it is moderate and it is the least. So nucleophile will attack first onto this. So A will be the more reactive when compared to B and C. Okay. Next, in 1,4 addition, what could be the reactivity order? So how to define the reactivity order in 1,4 additions? సో ఒకసారి మెకానిజం చూడండి. ఓకే, సో if a nucleophile need to attach or attack onto the fourth position or 1,4 addition, so what should be there at beta position? Is it should be electron deficient or electron excess? Electron deficient must be there. Okay, but is it going to attack directly? No. When it is a weak nucleophile, the before attacking of the nucleophile, the conjugation shifted to the oxygen so that it is going to form the carbocation onto this and oxide ion onto this. Then nucleophile will attack. Okay, so that is the scenario. Okay, actual reaction is going to happen in this way. So you need to see the carbocation formation which is more stable. Okay, సో ఇక్కడ మాత్రం న్యూక్లియోఫైల్ డైరెక్ట్ టచ్ అటాక్ అవుతుంది, ఎటువంటి చార్జ్ డిఫరెన్స్ లేకుండా ఆర్ పోలరైజేషన్ జరగక ముందే న్యూక్లియోఫైల్ అటాక్ అవుతుంది, ఎందుకంటే స్ట్రాంగ్ న్యూక్లియోఫైల్ కనుక. కానీ ఇక్కడ ఏం జరుగుతుంది, పోలరైజేషన్ ఆర్ డీలోకలైజేషన్ జరిగిన తర్వాత న్యూక్లియోఫైల్ అటాక్ అవుతుంది. సో డీలోకలైజేషన్ జరగాలి అంటే ఇక్కడ కార్బోకాటైన్ జనరేట్ అవ్వాలి. సో కార్బోకాటైన్ ఏదైతే స్టేబుల్గా ఉంటుందో బీటా కార్బోకాటైన్, ఓకే. సో మోర్ ది స్టెబిలిటీ of the beta carbocation is more the reactivity. Okay, so very careful with 1,4 addition. Okay, so you need to see the exact rearrangement pattern and exact reaction mechanism. So once it got turned into the carbocation, the reactivity is going to start. Okay, so reaction is going to perform. So you need to see the carbocation stability. So now which is the most reactive? So it is C because it's going to form a stable carbocation when compared to other two. Okay. So C will be the more reactive. Okay. B A na. Yeah, C B A. Okay. So this is when nucleophile is going to attack when charge separation is going to happen. Okay. So when charge separation is not there, okay, if it is strong nucleophile and in presence of copper you are treating, okay. So in presence of copper, if you are treating, then there is no charge separation will be there. Just copper will stabilize this, so this become weak, less electron deficient. Now the reactivity will be based on the nucleophile addition. Okay, so ఇక్కడ ఎలక్ట్రాన్ డెన్సిటీ ఏదైతే తక్కువ ఉంటుందో అప్పుడు జరుగుతుంది. ఓకే, సో 1,2 అడిషన్లోనేమో డైరెక్ట్ ఎలక్ట్రాన్ డెఫిషియంట్ పొజిషన్ మీద. ఓకే, 1,4 అడిషన్ చార్జ్ సపరేషన్ జరిగితే ఇలా. ఓకే, అదే 1,4 అడిషన్ చార్జ్ సపరేషన్ ఏం లేకుండా డైరెక్ట్ జరిగితే సో డైరెక్ట్ న్యూక్లియోఫైల్ మీద ఎలక్ట్రాన్ డెఫిషియంట్ పొజిషన్ మీద అటాక్ అవుతుంది. సో ఇఫ్ there is no charge separation, it will be in terms of if it is copper and everything, so there will be the attacking will be A B C. Okay, so it will be going to attack first, then this. Okay, so when there is a no charge separation. ఓకే, సో అది డిఫరెంట్ స్ట్రాంగ్ న్యూక్లియోఫైల్స్ వీక్ న్యూక్లియోఫైల్స్ మీద డిపెండ్ అయి ఉంటుంది. ఓకే, సో ఎప్పుడైతే మీకు వీక్ న్యూక్లియోఫైల్ అండ్ చార్జ్ సపరేషన్ అనేది జరుగుతుంది అప్పుడు అప్పుడు మనకి ఆర్డర్ వచ్చేసి కార్బోకాటైన్ స్టెబిలిటీ మీద ఉంటుంది. ఎప్పుడైతే కాపర్ అండ్ అదర్ మెటల్స్ ఉంటాయి అండ్ అటాకింగ్ ఉంటుంది అప్పుడు మనకి ఎలక్ట్రాన్ డెఫిషియెంట్ పొజిషన్ ఎక్కడ ఉంటే అక్కడ. ఓకే, సో వెన్ 1,4 పొజిషన్, if at beta position, if it is less electron density, okay, or more electron deficient, that's going to happen. Okay, so this is about the addition reactions based on the nucleophiles. Okay, so in the now we're going to see the free radical addition reactions. Okay, so before that I would like to give one clarity. So yesterday we discussed about the Stark enamine reaction, okay, with the regioselectivity. Means when there is a yeah, when there is a methyl group, okay, so at alpha position, let's say carbonyl and methyl group at alpha position. Okay, so if this is treated with pyrrolidine, so it's going to give the enamine which is less stable. Okay, so there are two possibilities. So in the last class we discussed with the regioselectivity where I have given this is more stable, but it is incorrect. So the thing is it will be more stable. Okay, it will be more stable because when it is forming a enamine, okay, enamine with the carbonyl. So this is going to be in the planar arrangement. Okay, when it is double bond is forming between the alpha carbon, substituted alpha carbon and the carbon which is holding the enamine. Okay, so there will be a planar arrangement between them. So based on the steric hindrance, okay, and crowding, sterical hindrance and steric repulsions, it will not allow the formation of enamine to the more substituted carbon. So this will be the more substituted. This will be the more stable enamine. Okay, so in the further reaction, it will be going to react. Okay, so there was a wrong reference in my notes. So yesterday I have given as this is more stable but not. So after finding the correct reference, it was found that so less substituted carbon side enamine is going to form, because if it is towards the more substituted side, it will be planar, so that it will repulse. Okay, is it clear? Okay, yeah. ఒకసారి క్వశ్చన్ రిపీట్ చేయి. మేజర్ మైనర్ ప్రొడక్ట్ అనేది యాక్చువల్‌గా ఒక రియాక్షన్ జరుగుతున్నప్పుడు 2, 1 ఇట్లా కాదు. There will be a many number of products based on the byproducts, based on the impurities, and based on the uh, stability factors. Okay, but outcome whatever will be there, it will be in the ratios. Okay, for example, when we are discussing about major and minor, okay, so why we are discussing only about the specific reactions? Why not all reactions we are discussing major minor? Means when there is a discussion arising, means there will be at least a 5% of the minor. Okay. Otherwise, there will be definitely other products other than the desired product, but they are very very negligible in other conditions. When it is a major and minor discussion, when there is a possibility of two or more products only, we going to discuss. Okay, so when this is the case, so the possibility of one formation or possibility of major product formation will be with more efficiency when compared to the minor product. Okay, సో దట్ ఈస్ ద సినారియో. ఒకవేళ మనం మాట్లాడుతున్నాము అంటే అది ఖచ్చితంగా మేజర్ మైనర్ ఇస్తుంది అన్నట్టు. ఓకే, అది కూడా చెప్పుకోదగ్గ రేంజ్లో లేదు. 1% ఆర్ బిలో 1% డెఫినెట్గా ఫామ్ అవుతాయి. సో దేంట్లోనైనా ఫామ్ అవుతాయి, ఎందుకంటే ఇంప్యూరిటీ ఉన్నా లేదంటే ఏదైనా రియేజెంట్ సిస్టమ్ కరెక్ట్ లేకున్నా ఆ రియేజెంట్ డిఫరెంట్గా అటాక్ చేసినా కానీ ఫామ్ అవుతాయి, బట్ చెప్పుకోదగ్గ రేంజ్లో ఉండవు, బికాజ్ యూ కాంట్ ఐసోలేట్ దెమ్. ఓకే, ఇస్ ఇట్ క్లియర్? సో I want to give one more uh, type of reaction for the nucleophilic addition reaction. So basically metal based hydrates, for example aluminum hydride, okay, and lithium aluminum hydride and sodium borohydride. So these are all are reducing agents. Okay, so which donate the hydride, okay, H minus. So reduction based on the H minus donation or hydrogen donation is also a nucleophilic addition. For example, if I use a carbonyl and treat with lithium aluminum hydride, so it's going to reduce by donating the H minus. Okay, so it's going to become O minus here. So hydrogen attacked, H hydride attacked here. Okay, so it become here. So it's going to abstract the proton from the solvent, resulting into the alcohols. Okay, so when hydrogen addition is going to take place, it is considered to be reduction. Okay, so metal based hydrides, okay, metal based hydrides will act or will attack as a nucleophile, so they are also considered as a nucleophilic addition reactions. Okay, So whatever the reductions based on lithium aluminum hydride, based on sodium borohydride, are considered to be nucleophilic addition reactions. Okay. So lithium aluminum hydride and sodium borohydride both are going to use to reduce the carbonyl systems into the alcohols. Okay, there are many other reductions with the sodium borohydride and lithium borohydride that we will be going to discuss in further classes. So, but so far you need to remember that. So these two are reducing agents which can reduce the carbonyl systems into the alcohol, and it is considered to be nucleophilic addition reaction. Okay. So next, free radical addition reaction. So basically free radical addition reaction is about the free radical additions of the halogens and other homodiatomic molecules. Okay. So when a halogen is treated in presence of the photolight, okay, halogen is treated in presence of the photolight, so it's going to give free radicals. Okay, so once the free radicals are formed, they are with a high energy, so high energy particles are going to form. Okay, these high energy particles will be going to attack onto the olefin systems. Okay, so olefin systems, so that it will be going to give the addition products. Okay, so when we are discussing about the addition, there must be unsaturation. When we are discussing about the free radicals addition reaction, it must generate the free radicals. Okay, so generally how free radicals are generated means either free radical initiators. Okay, either from the free radical initiator or from the photolites. Okay, so general free radical initiators will be peroxides. Okay, so peroxides, so for example benzyl peroxide, sorry, benzyl peroxide. You can, you just try to mute, so here a little disturbance is giving. So this is what benzyl peroxide, so it's going to break up here, so two radicals are going to form. Okay, those two radicals are going to attack onto the chlorine. Okay, so when it is like, so let me shorten this. So if peroxide is there, so it's going to break up in presence of photolite or uh, thermal condition, so it's going to give two RO radicals. So when it is radicals, so it is initiating the reaction. Okay, so it is starting of the reaction, so it will activate or it will results into the free radicals when it is going to attack onto the chlorine. So ROCl is going to form and Cl radical is going to form. So this radical generation from the reagent system, okay, not from the radical initiator, radicals generation from the reagent system is, is called chain initiation step. Okay, chain initiation step. Okay, so when radical initiation is going to happen, okay, so there is a formation of high energy free radicals. So this, if it is treated with the starting material, so it will be going to attack. Okay, so resulting into what? So when a carbocation is attacked, let's say carbon ion is attacked, nucleophile, so the charge will be minus. So when it is going to attack onto the olefin, so what could be the charge that is going to generate on the olefin? Negative charge. So whatever the charge that is going to take up by the alkene, so that will be going to reside on the alkane system. Okay, సో ఇక్కడ రాడికల్ తీసుకుంటుంది కనుక ఇక్కడ రాడికల్ ఫామ్ అవుతుంది. సో ఎక్కడ ఫామ్ అవ్వాలి అనేది దాని రీజియో సెలెక్టివిటీ అన్నట్టు. సో దేర్ ఆర్ టూ పాసిబిలిటీస్. సో వన్స్ ఇఫ్ ఇట్ ఈస్ అటాకింగ్ హియర్, here it will be the radical. Okay, and once it is attacking here, here it will be the radical formation. Okay, so among these two radicals 1 and 2, so first one is primary, second one is secondary, so which will be more stable? So which free radical is more stable? Secondary free radical will be more stable, so it will be going to give the further reaction. Okay, but the thing is, whatever the radical that is generated, okay, in the chain initiation step will going to perform, okay, will going to perform the radicals extension or radical generation until unless all the starting material converted into the product, okay, or further product level formation stages. Okay, so because this Cl whatever is formed, it will be going to attack and the one more molecule of chlorine. So again Cl2 is going to break into the Cl radicals, so that will be going to react with the starting material, again it is going to form. So radical formation will keep on going, so this will be called as a chain propagation reaction. Means the radical formation will propagate until the all the starting material will be converted into product. So once it is formed, so again one more radical is going to react with the secondary or more stable so the product formation step is called chain termination step. Okay, chain termination step, because the chain reaction whatever is there is terminated by the formation of the products. Okay, so until unless products are forming, there will be a chain propagation step, or the propagation of radicals is going to form. Okay, so it will extensive, so like a chain. So in free radical addition reaction there will be three steps. The first one chain initiation, second one chain propagation, third one chain termination. In the initiation, radical initiators will initiate the or generate the free radicals. In the propagation step, so radicals that are formed from the reagent system will be going to attack onto the starting material in a chain fashion. So until unless all the product converted into all the starting material converted into the product level, so this chain propagation step is going to follow up. Okay, so when the all the free radical combined together to give product is called chain termination step. Okay, so this is about the free radical addition reactions. Okay, so in the free radical addition reaction there is a important principle, so which is anti Markovnikov rule. Okay, or anti Markovnikov product. This is also called Kharash effect. Okay, Kharash effect. So anti-Markovnikov rule or principle is what? So what is Markovnikov principle? So it is about the unsymmetrical alkene if it is treated with unsymmetrical reagents. So the addition of negative moiety will be at more substituted carbon. Okay, and positive moiety will be at less substituted carbon, isn't it? So this is Markovnikov rule. So if I say anti, so it is what? Reverse. So reverse is going to what happen? So negative moiety must be at less substituted carbon, and the positive moiety must be at more substituted carbon. Okay, so this is what? Anti Markovnikov rule. Okay. Mm. So if it is anti-Markovnikov rule, here it is about the free radicals instead of the ion formation. Okay, so when it is going to happen in the reaction level means, so the same starting material unsymmetrical alkene and same reagent unsymmetrical reagent, but if it is in presence of the peroxide. Okay, if it is in the presence of peroxide, initially radicals are going to form. Okay, radicals are going to form, so H radical and Br radical. Okay, so let's make it in detail. So RO radicals are formed. So this is going to attack onto the HBr. So here it is a chain initiation reaction. So ROBr will be formed and H radical will be going to form. Okay. So in the initiation, hydrogen radicals are initiated. So this will be going to react with the alkene system. Okay. So when it is attacking, so there is a two possibilities. Hydrogen can attack here and radical can generate here, and hydrogen can attack here and radical can generate here. So this is primary and this is secondary. As secondary is more stable, so it will be going to react further with the bromine radical. Okay, so how it is going to react means, so when one more molecule of RO is treated with this one, so it is going to form again peroxide. Okay, or again radicals. Again, it is going to release the Br radical. Okay, so if this Br radical attached with the more stable or secondary radical, it's going to give this. Oh, sorry, I made some mistake. So thing is that when RO radical is going to attack, so it will be going to take up the H place. Okay, so ROH is going to form, which is more stable. Okay, so ROH and Br radical is going to form. This is going to attack. Okay, so in comparison with hydrogen radical and Br radical will be more stable because of the larger size. Okay, so that repulsions will be less. So this Br radical is going to attack onto the olefin system. Okay, so olefin system, if it is going to react with the Br radical, there are two possibilities. Bromine can attack here and radical can form here. Okay, and at the same time bromine can attack here and radical formation can be here. Okay, so among these two, this is secondary and this is primary, so it will be more reactive. So it's going to take up when further hydrogen radicals are released, or you can also find the radical formation from this itself. Okay, when one more Br radical is treating with HBr. Okay, so it's going to form Br2 and H radical. Okay, so radical formation will be extended in different ways once it is get initiated. Okay, so this H radical is going to attack onto the more substituted carbon, and bromine will be as usual it less substituted carbon. Okay, so whenever free radical is reacting, okay, whenever free radical mechanism, okay, so is followed up when the in presence of peroxides, then it is going to give anti-Markovnikov product. So this is Markovnikov product which is ionic mechanism. Okay, which is in ionic mechanism, and when it is in free radical mechanism, so anti-Markovnikov product will be formed. Okay, so for this formation of anti-Markovnikov product, there must be a free radical initiator, or there must be peroxide or per acids are also can make this change. Okay, so peroxide or per acids must be there. Okay, so this is the first condition, and second condition, they are similar to the Markovnikov unsymmetrical alkene unsymmetrical reagent. Okay, and third condition, this peroxide effect only possible with the bromine or HBr, not with the HCl or not with the HIHF. Okay, because they are not going to give the stable free radicals, or there will not be no regioselectivity with the free radical formation. Only peroxide effect is found in the HBr reactivity only. Okay, so this is about the anti-Markovnikov rule. Okay, so which is reverse to the Markovnikov addition. Okay, so try to work out some examples. So these are the workouts. So try to work out and send in the group. So the rest will be discussed tomorrow. Okay.